Hello everyone, welcome back. In front of us we have a moment problem and it reads calculate the magnitude of force F shown in the diagram below. So the question is asking us to find the magnitude F that is acting at a distance of 5 meters from the turning point O. But we have a problem here. We have 80 root 3 Newton force that is acting downwards, but it is not perpendicular to the distance from the turning point. So if you look at it, the distance here is 3 meters, but the force is not acting at right angles to the distance. If you remember, we define moment as the force multiplied by the perpendicular distance. Perpendicular distance to the line of force. So what that simply means is, let's say we have our turning point here, O. The distance S from the turning point must be perpendicular. That means must be at right angles to the force. So a moment is defined as the product of force and the perpendicular distance to the line of force, which simply means that the force and the distance must be at right angles. So we have a situation here which demands resolution. So we need to find the force that is exactly at 90 degrees to the distance. We can do this by resolving and finding that perpendicular force. So I can stretch a line that is going to come this way. If you analyze it, this line here is now going to be perpendicular to the distance because it's going to be 90 degrees between the force and the distance. Let's call that force P. So to complete this triangle, let me draw something like this and something like this. So this is a triangle of its own, here, here, and here. And this is also a triangle, here, here, and here. Then if this angle is 30 degrees here, obviously this angle here will also be 30 degrees. Do you know why? Let's say I am considering this triangle here. This angle here is going to be 90 degrees. And this is going to be 60 degrees because 90 plus 30 plus 60 will make 180 degrees sum of angles in a triangle. So if this is 60, then what do you add to 60 to make a right angle, to make 90 degrees? Is going to be 30. So that is why if this angle is 30, automatically this is also going to be 30. All right. Now, if I should derive the triangle that I have here, I have the force of 80 root 3 newtons. I have that perpendicular line P that I'm trying to find. And this is the 90 degree angle here. We've said that this is 30 degrees. So to find P, the trigonometric ratio is, we're going to say cos theta is equals to adjacent all over hypotenuse. So it means cos of 30 degrees is equal to the adjacent becomes P all over the hypotenuse becomes 80 root 3. So it means to find P is going to be 80 root 3 cos 30. That is P is equals to 120 newtons. Okay, so which means we have now been able to find the force that is perpendicular to the 3 meters distance. So to draw this on a rough sketch, I'll point here O, and we'll have a straight line here. We'll have a force F, and we have another force here that we have already found, P, which is 120 newtons. The distance here is 3 meters, and the distance from here is 2 meters. So now all the forces are perpendicular to their respective distances from the reference point. This is what we can use to find the magnitude of the force F. So the force acting clockwise is this, that's the clockwise moment. The force acting anti-clockwise is this, anti-clockwise moment. But remember, we've said that clockwise moment is equal to anti-clockwise moment. So taking moments from O, the force of 120 Newton is acting 3 meters away from O. So that will be 120 multiplied by 3 is equal to, if we are now considering the force F, it is acting perpendicular distance of 5 meters from the turning point O. So we're going to have F multiplied by 3 plus 2 is 5. So 120 multiplied by 3 gives 360. This is equals to 5F. To find F, you divide both sides by 5, both sides by 5. F will be 360 divided by 5, and that gives 72 newtons. So that is the magnitude F. We have another problem here, and it reads, calculate the magnitude of the forces R1 and R2. So here we are to determine the magnitude of R1 and R2. If you analyze this diagram, you will immediately notice that R1 is perpendicular to the distance from the reference point here. R2 is also perpendicular to its distance from the reference point here. But we do have two forces, the 20 root 3 Newton force and the 60 root 3 Newton force, which are not at right angles to the distance. So they are not perpendicular. To solve this, the forces that we have to use need to be perpendicular to the distance. So for the 20 root 3 Newton force, if we should resolve this, for the 20 root 3 Newton force, the force that has to be perpendicular to the 0.2 meters distance will have to come this way. And therefore I can call that force F1. If I should complete this as a triangle, I'm going to have a right angle triangle here, and the angle here will be 30 degrees. The same thing applies for the 60 root 3 Newton force. If I should find the perpendicular force, it has to come this way. And if I should complete the triangle, I will have a right angle triangle here. The angle here will also be 30 degrees. So I can call this force F2 as well. Considering F1, we will have a right angle triangle like this. So this will be F1, this will be 20 root 3, and this angle will be 30 degrees. If I use cos theta is equal to adjacent over hypotenuse, then cos of 30 degrees is equal to the adjacent will be F1 and the hypotenuse will be 20 root 3. So F1 will be 20 root 3 cos 30. And 20 root 3 cos 30 gives 30 newtons. So F1 is equals to 30 newtons. That is going to be the perpendicular force after we have resolved 20 root 3 newtons. So the same thing applies for the F2. If we have a triangle like this, and this side is F2, we have 60 root 3 newtons for this side, and the angle is 30 degrees. Again, using cos theta is equals to adjacent all over hypotenuse. Cos of 30 is equal to the adjacent will be F2 all over the hypotenuse will be 60 root 3. If you cross multiply, F2 will be 60 root 3 cos 30. Then F2 will be 90 newtons. So we already know the value of F1, which is 30 degrees, and the value of F2. These are the forces that are perpendicular to their respective distances. So if we should draw this diagram again, then we will have something like this, where F1 is indicated here and F2 is indicated here. So the forces that I am now dealing with, they are all perpendicular to their respective distances from the reference point O. All right, so we can now move on. From the principles of moment, we've said that the upward forces must be equal to downward forces. So the upward forces are R1 plus R2. This must be equal to the downward forces. We have the 30 newtons plus the 90 newtons force. So R1 plus R2 is equal to 120 newtons. We also have another principle of moment which states clockwise moments must be equal to anti-clockwise moments. So let's go and identify our clockwise moments. So if O is the reference point or the pivot, the 30 Newton force is going to act clockwise. So it's going to be a clockwise moment. The 90 Newton also will be a force that is going to act clockwise. So we have a clockwise moment for the 90 newtons. The R1 is going to act anti-clockwise. So that's an anti-clockwise moment. The R2 is also going to act anti-clockwise. So we have anti-clockwise moment for R2. Okay. We already know moment is force times distance. So let's move on. For the 30 Newton is acting clockwise, is 30 multiplied by the distance from the reference point is just 0.2 meters. So that will be 30 times 0.2 plus, for the 90 Newton, it will be 90 times the distance from the reference point. That will be 0.1, 0.1, 0.2. And that is going to give you 0.4. So that will be 90 times 0.4. This is equal to the anti-clockwise moments. We have R1 multiplied by the perpendicular distance from the reference point is 0.1, 0.2. Okay, so that will give you 0.3 plus R2 multiplied by R2, the distance is 0.4, 0.1, 0.1, 0.2 from the reference point. That is 0.8 in total. So that will be R2 multiplied by 0.8. So if we continue solving, 30 multiplied by 0.2 is 6 plus 90 multiplied by 0.4 gives 36. This is equal to R1 multiplied by 0.3 is 0.3 R1 plus R2 multiplied by 0.8 is 0.8 R2. 6 plus 36 is 42. This is equal to 0.3 R1 plus 0.8 R2. Okay. At this stage, I can call this equation 1 and this as equation 2. So from equation 1, R1 plus R2, we say it is equal to 120 newtons. So I can make any of them the subject of the formula so that I can be able to substitute it in equation 2. Let's say I want to make R2 the subject of the formula. Therefore, R2 is equals to 120 minus R1. So substituting, R2 is equals to 120 minus R1 of equation 1 into equation 2. What do we get? First, what is equation 2? Is 42 is equals to 0.3 R1 plus 0.8 R2. Then 42 is equals to 0.3 R1 plus 0.8 into what is R2, 120 minus R1. So 42 is equals to 0.3 R1 plus 0.8 multiplied by 120 is 96. 0.8 multiplied by negative R1, you'll have negative 0.8 R1. Collecting like terms, you will have 42 minus 96 is equals to 0.3 R1 minus 0.8 R1. 42 minus 96 is minus 54 is equal to 0.3 R1 minus 0.8 R1 will have minus 0.5 R1. So because we have negative on both sides, negative will cancel. Then 54 is equals to 0.5 R1. To find R1, we'll divide both sides by 0.5, both sides by 0.5. So 0.5 cancels 0.5, and we'll have R1 is equal to 54 divided by 0.5. That is 108 newtons. All right, so we are able to find R1. To find R2, we say using R2 is equal to 120 minus R1, then R2 is equals to 120 minus 108. So R2 is equals to 12 newtons. So that answers the question. Thank you very much for your attention. If this is the first time visiting this channel or watching any of our videos, please do not forget to subscribe, like, and share our videos to your friends who could potentially benefit from our lessons. We will be uploading videos frequently on physics, mathematics, biology, and chemistry. So that is why subscribing to this channel will be helpful to you. Thank you very much.